Alright, so finally after setting the Active Directory Pentest lab in session 3, welcome to session 4. Here is where the actual attacking starts. So we are going to attack Active Directory from this session onwards. Now initially we are going to start with initial attack vectors. There are other vectors which require some kind of a compromise like credentials or lateral movement, but we are going to start with initial attack vectors because in reality we are going to have to first find our way into the network when we start a pen test, especially an internal pen test, right? So we just have a machine during an internal pen test and we are dropped into the network. Typically you're remote and you just RDP into the machine. Sometimes maybe you're on site and you're working on your laptop, but you're just dropped into the network. You're given no credentials, you're given nothing. So we shall go through how we can abuse the features of Windows. The key point to note is we are going to be abusing the features and not the misconfigurations. So yes, we'll be abusing the features and utilize those to get access to user account credentials and get access to machines as well. With that said, let's start the first attack. So the attack name is LLMNR Poisoning. What is LLMNR? LLMNR stands for Link Local Multicast Name Resolution. This protocol is used to identify hosts when DNS fails to do so. It was also previously known as NBT-NS, which stands for NetBIOS Name Service. The key flaw in this protocol is that when we respond to this service, the service in turn responds back to us with the username and password hash. So we are going to be doing some really malicious stuff using the password hashes, right? We can try to crack them, take them offline, and we can also pass the hash around and find access to other machines in the network. But the key flaw over here in LLMNR poisoning is that the service utilizes a user's username and NTLM v2 hash when appropriately responded to. Now we are going to look at a demonstration of how to perform an LLMNR poisoning. So let's have a first quick overview about what LLMNR poisoning really means. So imagine this scenario. We have a victim mission, and if you remember from our session 2, we have created a shared folder using the domain controller named hackme. Alright, so in reality the server name was hackme, that's the point. But in this request that the user has sent, he says, hey, can you connect me to that //hackm? Alright, so he just happened to do a typo or he just misspelled hackme, right? So this causes a DNS issue because the DNS is going to be responding back to the victim saying, hey, I have no idea what you're talking about, right? So the DNS is going to respond to that. So the victim machine now sends a broadcast message saying, does anyone know what hackm is or where I can go to connect to this share? Now we are going to be acting as the man in the middle and we are going to respond saying, hey, I know where the hackm is lying and you will have to send me your hashes and I will connect you right away. So believing us, the victim machine is going to send us the hashes and the username of the NTLM authentication, and we are going to do a lot of stuff with the hashes. Alright, so this is the key mechanism of the LLMNR poisoning. Now let's look at the strategy that we are going to follow before I actually get into the live demonstration. So we are going to be using a tool named Responder. It is a part of the Impacket toolkit. If you do not have experience using Impacket toolkit, I highly recommend you to go and explore using that toolkit. You can just git clone the Impacket repository from the internet. Alright, so we will be running Responder. Now Responder is going to be listening for the incoming requests and act as the man in the middle, and it is going to be responding for all the requests which DNS fails to resolve. So we are not in an actual network, right? So this is a simulation of an actual Active Directory. So in this case, we are going to go to either a user machine like Frank Castle or Peter Parker in our case, right? So we'll go to Frank Castle's machine, let's say, and we are manually going to cause this error, which is going to cause a DNS resolving issue. In reality, it is often the users that do it, and there are multiple issues that DNS cannot resolve, right? So this is just one of them. So we will point the IP address of our attacker machine and cause a DNS failure, and boom, the responder is going to capture all the hashes. It's also going to find out the domain user's name. So we are going to be looking at some really sensitive information, right? So we'll be able to capture these. Once we capture the hashes, we can use another tool called hashcat, and we can try to take the hash offline and crack it. So with that said, let's get started at the live demonstration of LLMNR poisoning. Alright, so here's our Kali machine, here's our attacker machine, and we have to install Impacket. Now since I have already installed it, I will just show you just so that you do not end up downloading something else. So Impacket GitHub, you can just Google it. And this right here by Secure Auth Corp is what we are looking for. So go ahead and clone this repository and do the initial requirements setup as mentioned in the documentation. A simple pip install dot should do. So once Impacket is installed, we can now come here and we will start up our responder tool. Alright, so let's tab responder -i for interface, eth0 because that is the interface that we are going to be listening on. Let's just check if that's the interface. So ifconfig, yes, that's the interface that we are going to be listening on. So eth0 and flags -rdwv. So you do not have to worry a lot about these flags. So there are always the help documentations that you can take a look at for the flags meanings. So for instance, W over here means WPAD and V is for verbose. So you can just go and have a look at --help after responder. So let's start up our responder. Now you can see that it is running a number of different servers, right? So it is running SMB server, HTTP. Okay, SMB server is off for some reason. All right, so let's quit responder. Let's go edit responder.conf. Alright, so alright, SMB is turned to off. Let's make it on. Let's turn on HTTP as well. I think I had manually set these to off in order to demonstrate another video that we will talk about in another session. So with that done, let's go fire up responder. Alright, so now you can see there's different servers that responder is running, right? So it is going to be listening to requests on all of these different servers: HTTP, SMB, IMAP, POP3, SMTP, LDAP, etc., etc. And it is going to be responding for protocols LLMNR, NBT-NS, DNS. So remember, if a DNS failure happens, it is going to look into LLMNR, and if an LLMNR failure happens, it is going to look into NBT-NS. Alright, so let's go to our second step and cause an error in Frank Castle's machine. If I can remember the password. Alright, yeah. So go to File Explorer and let's say in the file share, we will just make it point to our attacker machine. So //point. Alright, so this did not cause a DNS issue. Alright, we are trying to access the SMB, right? And we do know that SMB is running. But take a look at what just came here. We got the password hashes of Frank Castle, and now we can do a lot of stuff with this hash. Alright, So we can take the offline and we can try to crack the hash using tools like hashcat. So we will take a look at that as well next. Alright, so let's go ahead and capture this hash and save it in a file. Now, let me tell you a small strategy that I use. Alright, so we are going to be using hashcat as a tool for cracking the hash that we have just captured. Now hashcat can be run on our attacker machine, but since we are running our attacker machine on a VM, we will not be able to use our GPU. Instead, we'll be using our CPU. And that is really slow, alright? That is really slow. We want to use our GPU, alright? We need a good rig to crack the hashes. So we need to use our GPU. So I would suggest that you install hashcat on your base OS. Now my base OS is Windows, so I am going to be running hashcat on Windows. But yes, definitely feel free to go and run it on the CPU if you cannot run it on the GPU. It's totally alright. So let's first copy this hash. Go ahead. Alright, so I have saved my hash. Now let's take a look at hashcat. So there are these multiple options that hashcat offers to crack different types of hashes, right? So we in our case want to crack a NTLM hash. So we need to take a look at where NTLM is. But this is where a little bit of our Linux foo can help us. So let's just grep NTLM. Alright, and we want to be using this 5600 module. So go ahead and write hashcat -n 5600. Throw your NTLM hash file at it, and now we need to give a word list, right? And I will just show you where our word list is. So give /user share word list rocku.txt. In case you do not have rocku.txt, you should be having rocku.txt.gz. Go ahead and extract that file. Alright. And then if you're running it in the VM, go ahead and give --force. This will enable it to run it on the VM using the CPU. But I am not going to do that. Instead, I will show you how to run it on a Windows machine just like I usually do. So this is where my Windows hashcat is. You can just go and Google for hashcat Windows. Right? Alright, so hashcat download. Go ahead. You can find the different binary files and go download that binary file right there. Now, once that is done, I have copied my rocku.txt file over here. Let's copy the hash as well. So let's copy our hash as well. Alright, I'm sorry. We need to go back to our Linux machine. Copy this hash. Come back here. Put it over here. And saved it. Now let's open up our command prompt. Alright. Now hashcat 64.exe not bin -m5600, the same old NTLM hash.txt. Okay, I've given .txt. Oh, alright, never mind. It's just a file type error. Doesn't matter. rocku.txt. And now you can just go ahead and start it. Well, it took a time. It also said my device fan speed is not supported. Yeah, if you have a better rig, you're likely to not get that error, but I did. So anyway, we have managed to crack the hash, and you can see that Frank Castle's hash maps to password 1 at Q. So we have cracked our password successfully. Okay, so that is the end for demonstration of our LLMNR poisoning attack. You can see that we were dropped onto this machine. We acted as a man in the middle. We captured some hashes, threw it offline, and cracked it using hashcat. This is just amazing, right? This is like the most amazing part of an internal PT, to be able to crack hashes, to be able to find very sensitive information. Now, I will quickly tell you about a few strategies that you can write in your report in case LLMNR poisoning attack is pulled off successfully. Alright, so let's talk about defenses for LLMNR poisoning. The very first defense, and the best defense, obviously the go-to strategy, is to disable LLMNR and NBT-NS on a network. Alright, so you can just Google up how to disable LLMNR, and you can also Google for how to disable NBT-NS. Now, say a company must use or cannot disable LLMNR or NBT-NS in some kind of a situation, right? Now, what can they do? What is their best course of action? So one point that they can do is they can make it necessary to require network access control, so they can implement an NAC. Second, they require a really good password complexity policy. So they must enforce the policy and make sure that the domain users or any of the users in general are using really strong user passwords, because the more complex the password is, the harder it is for an attacker to crack the hash. Alright, so this is how we come to an end of LLMNR poisoning. And next we are going to be talking about utilizing LLMNR poisoning to our own advantage in other ways, and not just capture a hash and crack it, but actually use that hash to our advantage to gain access to a machine. Alright, see you in the next session. Until then, happy hacking.